Welcome back to my YouTube channel. Today we'll be looking at trigonometric Fourier series. So that is what we'll be looking at. So we'll be looking at how to expand a function using the trigonometric Fourier series. Okay, so what do we really mean by expanding a function in trigonometric Fourier series? So let us consider this. So this definition says, let f of x be a periodic function of period 2 pi. So we know what that means. It is a function that has a period at 2 pi. So by the trigonometric Fourier series of f of x, we mean trigonometric series of this form. Of the form. Hold on, please. So of the form 1 over 2 a naught plus summation n equals 1 to infinity of en cos nx plus bn sin nx. So this is what we mean. So they said expand f of s in trigonometric Fourier series of a function of this function. So this is what we meant. Now the a naught, an, and then bn are the Fourier constants. The Fourier, we call them the Fourier constants. Okay, and they have a value. There is a way we evaluate them. So the a naught, so I'm not showing us how we get this formula in this video. So in the next video that we will be considering, I'll be showing us how we derive all this. So the a naught is 1 over pi integral from minus pi to pi of f of x dx. So why am I taking my integral from this to this? Is because the s we are considering has an interval of minus pi and pi to minus pi. Okay, so that is why the integral will go like that. Then for the an, it is 1 over pi integral from minus pi to pi f of x then cos nx dx. Then the bn is 1 over pi integral from minus pi to pi f of s sin ns ds. So these are the constant. This is how you get the constant. So once you evaluate the three constants, you bring them back into this formula, and that will be your Fourier expression of that function. Okay, so let's look at this example. All right, so we have this problem. It says obtain the trigonometric Fourier series expansion of the function f of x equals to s squared and f of x plus 2 pi is equals to f of x. So this is a question now. So we are asked to expand f of x using the trigonometric Fourier series. So to do that, we just have to remind ourselves what is the trigonometric Fourier series. It is what? It is 1 over 2 a naught plus summation n equals 1 to infinity of an cos nx plus bn sin nx. So here the a naught is equal to 1 over pi from what now? Here it will be 0 to 2 pi because they give us s is between 0 to 2 pi. Then you have your f of x dx. So we'll come back to evaluate that. So just write the formula out so that everything will be well spelled out. Then we have cos nx dx, and the last one is bn. So bn is 1 over pi integral from 0 to 2 pi f of x sin nx dx. So now let's consider each of them one by one. So let's consider the a naught. So we have the 1 over pi integral from 0 to pi of f of x. F of x is s squared ds. So if you integrate s squared, you get s raised to the power of 3 over 3 from 0 to 2 pi. Okay, so 1 over pi So if I put 2 pi there, I'll get 2 pi raised power of 3 over 3. So that will give me 8 pi raised power of 3 over pi times 3. Pi will cancel out of those 3 pi, you'll be left with 2 pi then divided by 3. So this becomes your A naught. Now to get your an is 1 over pi integral from 0 to 2 pi of x squared, now f of x, then cos nx dx. Alright, so to evaluate this, let us know what this integral will be, this one. So we take a break, let's get the integral of this. So we are going to be using the DI method. So using the DI method, you just have to write D and then you write the I. So the D is the part you are differentiating, the I is the part you are integrating. So for this case, your s squared should be the one you differentiate and your cos should be the one you integrate. Okay, so let's get started. So now you differentiate this, you get 2x. You integrate cos nx, you get sine nx over n. So you keep on differentiating. If you differentiate this, you get 2. If you differentiate this, you get minus cos nx over n squared. There is an n before, you are bringing additional n, so it become n squared. So the last step is to differentiate this, you get 0, and integrate this, you get minus sine ns over n cube. So after doing all this, you have to add the sign to the back. This is plus, minus, plus, and then minus. Now this first s squared, you cross it to this part. This 2s, you cross it to this part. This 2, you cross it to this part. So after doing that, you write down your question again, ds cos n s ds. So what do we get? So we have, so the positive sign will go in first. So s squared times sine nx, sine s squared times this, you get s squared sine ns over n. There is a plus here, so it remains the same. But here we have minus. Minus times this plus give us plus. So plus, then you have 2s cos nx over n squared. So the last one is the one of these two. So we have plus times minus, you get minus. Then 2 times this gives you 2 sine nx over what? N cube. So that is the answer for that integral. So we are going to put that answer in front of that an. So you come back and write your an. Okay, you come back and write your an. So an is 1 over pi integral from 0 to 2 pi of x squared cos ns ds. 1 over pi. So we'll evaluate this integral. Alright, so we've already evaluated this integral and we got s squared sine nx over n plus 2x cos nx over n squared minus 2 sine nx over n cube. This is what we got. So we are going to add the upper and lower limit, which is 0 to 2 pi. So we are going to add those two limits. So because of space, 1 over pi, now you open a bracket. So now you put 2 pi. So you get 2 pi all squared sine n times 2 pi divided by n plus 2 times 2 pi cos n, then 2 pi divided by n squared minus 2 sine n 2 pi divided by n cube. So you write minus and then open a bracket. Okay, so here, so putting 0 now, so once you put your upper limit, you write in minus, then you put the lower limit. So you use a semi bracket now. So you put 0, you get 0 squared, then cos 0, sorry, sine sine 0 over n now, plus 2 times 0 cos 0 over n squared, minus 2 sine 0 over n cubed. So you close your brackets. So now an is equal to so this will give you 4 pi squared, everything squared. Then here you see sine, anytime there is a pi attached to sine, it is always 0. You get, so I don't even need to write this part. You don't need to write that part. So you just have to know that the whole of that is 0. So you need to save time in an exam condition, on an exam setting. So this guy will give us 0. Okay, this one too has a pi in it, everything is 0. Then this one is sine 0 is 0, sine 0 is 0, and if you look at it, cos 0, and there is a 0 times in the cos, so everybody is 0 here. So the only person that is surviving this erosion is this center one, which is this 2 into 2 pi cos what, 2 cos n, then 2 pi over what, n squared. So this is the only person that survived. So if you times that, you get 4 pi, you get 1 over pi, 4 pi, then cos 2, okay, let's say cos 2n pi over n squared. Now I want you to observe the behavior of that cos. We are still coming back to write the answer. Now look at it. When for that cos function, when n is equal to 1, what happened to the cos n pi? What happened to it? So when n is 1, the cos function will give you 1. When n is 2, you still get 1. When n is 3, you still get 1. This cos will always give you 1. So for whatever value you put, you always get 1. So we can just say that this whole thing at the top is 1. So it's just like, see, because of this 2 pi, you always get 1. You get, it's just like if n is 1, you get cos 360. Cos 360 is 1. If it is 2 cos 720, that one is still 1. You can verify with using your calculator. So at the end of the day, we have 4 pi times 1 over pi n squared. So if pi cancel pi, you'll be left with 4 over n squared. So that will be your final answer. So our an is equals to 4n squared. I want to remove that. Okay. So let me erase this. So that is just an explanation on how the cos changed to 1. So all those things inside this, that is inside this cos, they are all angles. So you evaluate it when you get to that point. So let's go to the Bn. Now our Bn is 1 over pi integral from 0 to 2 pi f of x then sine nx dx. So this should be this 0 to 2 pi f of x is s squared then sine what, nx dx. Now you use your di method to evaluate integral of this before you even continue. So just like the one I did previously. So using the di method now, so we have the s squared and then we also have the sine nx. So if you differentiate this, you get 2x. Integrate this, you get minus cos nx over n. So moving on, if you differentiate the 2s, you get 2. Differentiate this, you get minus sine nx over n squared. Then the last one, you get 0, and then if you integrate this again, you get plus, because if you integrate sine, you get plus minus cos. So that minus will times this minus to give you plus. So you get plus cos nx over n cubed. So this is positive, this is negative, this is positive, this is negative. I stop here because I've already have 0 on the derivative. I can't further differentiate again. So your s squared will times this will times this, and this will times this. So what do you do next? You now write that we are done though. So you say sine nx dx now is equal to s squared, okay, minus, because plus times minus give you minus. Then you say s squared cos nx over n. Then the next one, minus times minus give you plus. You say 2s sine nx over what, n squared. Then the last one will give you plus. You get 2 cos nx over n cubed. So this is the final answer, plus minus. Okay, so let's go back to our Bn. So Bn is what? Bn is integral from 0, Bn is 1 over pi integral from 0 to 2 pi of s squared sine nx dx. Okay, so we already know what that integral will be. It is minus s squared cos nx over n plus 2s sine nx over n squared plus 2 cos nx over n squared. Don't mind my x. N cubed. Okay, then from 0 to 2 pi. So let's evaluate this. So Bn is equals to 1 over pi. So you put minus, then you write 2 pi all squared, then cos n times 2 pi over n plus 2 times 2 pi sine n times 2 pi over n squared plus 2 cos n times 2 pi over n cubed minus, then you start out of 0, minus 0 squared cos 0 over n plus 2 times 0 sine 0 over n squared plus 2 cos 0 over n cubed. So Bn now is equal to 1 over pi into bracket. So this will give you, okay, before you start this, I've told you that wherever there is a pi together with the sign, it always gives you 0. So this guy is 0, and this other one, 0 times cos gives 0. Then sine 2 will give you, this sine 0 is still 0. So the only person that will survive here is this first one, 4 pi squared cos 2n pi over n, this one plus 2 cos 2n pi over n cube, so minus into brackets. So it's only this last person that will survive, because cos 0 is not 0. Don't say it is 0. Okay, so we now have this. There is a plus here. Okay, so the next thing, we can open that bracket though. So if we open that, we have 4 pi squared cos 2n, okay, doesn't mean, over n plus 2 cos 2n pi over n cube minus 2 cos 0 over n cube. So the question is, what is cos 0? Cos 0 is 1. What is cos 2n pi? So this cos 2n pi will give you 1 for all n, for any n you pick. All the n that you pick, you put inside here, you still get 1. But this is a remark. If I have cos just n pi, this one alternates. It changes from 1 to minus 1. 1 to minus 1. So this one, we used to say it is equals to minus 1 raised power of n. Minus 1 raised power of n. But for this one, 2n pi, it is 1. For any value of n you put, you always get 1. So it is 1. So let's continue. So I will write 4 pi squared. This whole thing is 1. So I get 1. The other one too is 1. Sorry, there is over n here. Cos is 1. Cos 0 is 1. So you get this. So now we have 1 over pi. What else? Minus 4 pi squared over n plus 2 over n cube minus 2 over n cube. So you can see that these two expressions are the same. So it means that your Bn is equals to 1 over pi into minus 4 squared over n. So if the pi cancel one of the pi, you are left with 4 pi over n. You'll be left with 4 pi over n. Minus 4 pi over n. So remember, your n is from 1 all the way to infinity. So we are done. So at the end of the day, we have a naught to be what? Let us just summarize. Our a naught was 8 pi squared over 3. Our a naught, an is our an was let me go up. The an we got was 4 over n squared. And then our Bn is what we just had, 4 pi over n. So these are the answers. So you come back to your original expression, 1 over 2 a naught plus summation n equals 1 to infinity an cos nx plus bn sin nx. Okay, so now f of s was given to be s squared. Our a naught is 8 pi squared over 3 plus summation n equals 1 to infinity. An is 4 cos nx. So 4 over what? N squared. Then our bn is minus 4 pi over n sin what? Nx. So, but 2 can cancel the 4, the 8, you get pi squared over 3 plus summation n equals 1 to infinity 4 over n squared cos nx minus 4 pi over n sin nx. So this will be the final result. Thank you very much.